Yes, I'm here.
Good morning, doctor.
Morning.
Yeah, I think we have seen each other like a lot during this
Yes.
past maybe 2 years.
Are you doing
Okay.
your master?
Not yet, doctor.
Okay.
Okay. So, ladies and gentlemen, without further ado, let's start our meeting by listening to our national anthem, Indonesia Raya. Please remain quiet and in proper position. Thank you. Now, I would like to invite Dr. Rimulyo Hendradi, the coordinator of Bachelor Degree of Information System Study Program Universiti Airlangga, to deliver his welcome remarks. For Dr. Rimulyo Hendradi, time is yours.
Good morning, everyone. Healthy greeting always for all of you. Assalamualaikum warahmatullahi wabarakatuh. Today, it is a privilege for us to have special invited speaker for workshop who will present about Introduction to Machine Learning to Support Sustainable Development Goals using WEKA. I would like to express my gratitude for the willingness of Associate Professor Dr. Waidah Ismail from Faculty of Science and Technology, University Sains Islam Malaysia, to share knowledge and new insights in today's lecture. Welcome to Universitas Airlangga, Doctor. Even in virtually, we hope in the future you can please attend and stay again at Surabaya. Hopefully, what your connect sharing is very useful and helpful for all of us. Let's see together the presentation of knowledge sharing from Associate Professor Dr. Waidah Ismail. Wassalamualaikum warahmatullahi wabarakatuh. I return back to Mr. Halim.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the welcome remarks from Dr. Rimulyo Hendradi. Now, ladies and gentlemen, we are going to the next session. We are going to have training sessions, but before that, I would like to remind everyone to, first of all, please start your camera and also use the virtual background. I see some people here are using the virtual background already, but still many of you guys haven't started your camera. So it would be nice for us to be able to see your faces and also the virtual background. And also the second of all, I would like to remind everyone, as it has already been shared by our administrator today, the link to download the application that we are going to use for today's workshop, which is WEKA. The link has already been sent again in the chat. I would like to remind everyone to be ready to install WEKA. At least you can download it now. and we are going to go to the first training session. It's about data and also machine learning. But before that, I would like to invite our speakers, Associate Professor Dr. Waidah Ismail. Hello, Doctor.
Yes.
Okay. Ladies and gentlemen, I would like to firstly read about her biography. Okay, so Associate Professor Dr. Waidah Ismail is an Associate Professor in Faculty of Science and Technology in University Science Islam Malaysia, or USIM. She obtained her PhD in Information System and Computer from Brunei University, UK. Brunel University, I'm sorry, UK. Her first education in Diploma in Computer Science and Master of Information Technology from University Technology Mara, Malaysia in 1994 and 2005. And her honors computer science in University of Liverpool, UK. The areas that she interested in is artificial intelligence, including classification, heuristic search, and image processing. Her interests related to data analytical, machine learning, optimization, and Internet of Things. She received a few fundings from Malaysian government, Malaysian Newton Fund, Ungku Omar, and also USIM. Most of her paper published in WOS and Scopus indexes, and she has 10 years of experiences in the industry. Ladies and gentlemen, without further ado, I would like to welcome Associate Professor Dr. Waidah Ismail to start our workshop session today with the first session. And for Professor Dr. Waidah Ismail, time is yours.
Thank you, Halim. I think I met you a few times.
Yes, that's
You're
correct.
working in Unai or still study? I think you are in the final.
No.
I think you already finished.
No, my target is to finish this semester, but I'm not finished yet. And I'm still currently a bachelor degree student.
Oh,
I'm in the
okay.
7th semester. So, yeah.
Yeah, I saw you a lot. Okay,
Yeah.
I will share the PowerPoint. Can you everyone see?
Yes.
Okay. So, Assalamualaikum and good morning. So today, more on the knowledge sharing is something like free and easy. So anyone can ask. Sometimes I'm also not aware about the WEKA. If someone know better, then you can share it with everyone. So it's something like learning together. So today is introduction to machine learning to support the sustainability developed using the WEKA. So this is around the itinerary today. Itinerary today. Ice breaking. Mostly is a student and lecturer, is it? Most of the participant is the student and lecturers. Okay. Okay, so we will discuss about the data, understand about the machine learning, then we have a break around 50 minutes, then we hands on the WEKA. I think we can also hands on the WEKA. It depends on the time. So 10:45 to 12:30, understand about WEKA and the WEKA hands on. And also we have a lunch 12:30 to 2 because you need to have a prayer time, everything. So it's a bit longer. So 2 to 4 is a WEKA hands-on. So as Halim informed that, yes, this is my education background. And yes, this is my working experience. And recently I got my Microsoft Data Fundamental and Microsoft AI Fundamental certification. I think if you are a student or lecturer, if you have opportunity, please take the Microsoft Data Fundamental and Microsoft AI Fundamental. Actually, it's a very good training. It's more deeper and more understand. But Microsoft is more on the Microsoft application. It's really good. I love it. But I will take the examination the next stage, inshallah. So the objective is today understand type of the data. Before you use to do the analytical or to do anything, you need to understand what are the data. So understand machine learning, data mining, what are the different, because usually WEKA people, mostly WEKA is data mining, but you need to know what are the differentiate machine learning and data mining. I think that machine learning is inside data mining, because data mining is more on the playing about the data, how to preparation of the data, and machine learning is about the model. So the WEKA hands-on algorithm in the machine learning. So in the WEKA, there is a few algorithms that I'm familiar with that I can share with you. So what is the data? As you all know, data consists of raw data, and data is meaningless. This is one of my project data. As you show that the data is meaningless, you did not, how you want to analyze the data when you got the data. So this is type of the data, structured data. As a computer science, hold on, I take my marker. So as a computer science or who people who has a background in IT, structured data is the normal data that we always play around with, which is that we have a record and what are the field. Record, what are the field. This is the attitude. Okay. This is the attitude. This is the attributes. And this is the record, and this is the field. So this is the structured data. Usually what we have is a structured data. This is semi-structured data that you can see the name, the age. Usually in the semi-structured, they are using on the web. And this is structured data, which is on the voice, video, and this is I sharing with one of my images, blood cell. Later I will show what I did WEKA in my PhD. I did WEKA the last part on the validation, and this is all the unstructured data. So before you run anything or any algorithm, you need to understand your data. What type of your data? So type of data, there is two, qualitative and quantitative. Usually when we mention the qualitative, usually is more on the questionnaire. But in the qualitative, it's not only the questionnaire, but there is more on the categorizing. Later I will explain more. In the qualitative, there is a two type, nominal or ordinary. On the quantitative, there is a discrete data and continuous data. So before you run WEKA also, or any algorithm, you need to know which type of your data. So this is the foundation to about the data. Qualitative. Qualitative data cannot be expressed as number and cannot be measured. The qualitative consists of the images, video, pictures, and not number, but qualitative. But qualitative, there is a type of nominal data, which is there is a label. Labeling of the data. Labeling data without any type of the quantitative value. So in the nominal data is a facts. The eye color types. Everyone have a eye color like brown to yellow? No. There is a black, blue, gray, This is the color type that is already fixed. Smartphone, iPhone, Samsung, Nokia. There is a fax. There is not in between. And transportation, there is a aeroplane. Aeroplane, lorry, bus. This is the nominal data. Ordinary data. This is more on related with qualitative data. It's data which is placed order by their position or scale. If you do the questionnaire data, there is a linked scale, 1 to 5, everything. So you have a senior, that are demographic. Junior, the education level, high, bachelor, degree, master, satisfied, extremely satisfied, quite satisfied, slightly dissatisfied, extremely dissatisfied. This is the competition and this is the grade. So this is the qualitative data. That means you have to know there is a 2 types, nominal and also ordinary data. Quantitative data. There is a discrete data that mentioned that it's a count that involves only integer. That the discrete data cannot divide it into part which you cannot count 1.5 kids. Usually number of students in class, number of Facebook of like, number of vote of election. So this is the discrete data. But the continuous data, that means the discrete data is a fax number, student, Facebook, everything. But the continuous data, for example, a meaningful divided by final level, which is you have a sometimes decimal number. Speed of car, height of the children, average of temperature, which is continuous data. Do you know the weather? What are the weather in Indonesia? Today, tomorrow, every day. There is a continuous of the data. So this is the type of data that you all should understand before you start your analytical. So that you understand what are the output that required. Okay, after you understand the data, you know that the data is a raw data. You want to make sure that the data is informative, which is a information. This is example that the raw data that I come up with the result. From the data here, I analyze and I come up with this graph. This is more information rather than you give the user your raw data. So usually the data is preferable about the graphical. Later, I just explore one of the tools is a Google visualization. I will share towards the end of the lecture. So this is how you visualize the data. So data analytical, usually we want to make sure that last time when I study data into the information to a knowledge, but knowledge to the wisdom. That means knowledge is more, is a sharing. That means it's more like knowledge is something like deeper that you can know better. What I mean is more on the visual. Like for example, when you did a visualization like this, this is the information. But from here, we can understand that this patient is not doing well in this state. You know, wisdom is more you, from the graph, you can define more. So this is the difference between the data mining and the machine learning. So data mining, what is that? It's designed the abstract rules of the large of the data. So discover the new and accurate and useful pattern in the data, looking the meaningful, relevant in the organization and individual, the tools used by the human. So data mining, we are using the WEKA. So machine learning, discover the algorithm that has improved, derived from the data. So it is designed to study, develop an algorithm machine without the human intervention, the tools that machine look smarter. So when I did my PhD, I did WEKA to validate. One thing is good when you are doing your master or PhD or during your study, when you got the data, you can run the data inside the WEKA. Later, you know what are the best method, what are the good method for your data, then you can develop it. That means you can do a coding using the Python. Later I will show. So machine learning algorithm build a model on the sample data known as the training data in order to make a predictions or decision without being the explicit program to do. Machine learning focus on the development of the computer program. So machine learning later also you have a training data. So the process of learning begins the observation of the data, such as example, direct experience, instruction in order to look a pattern in data, make a better decision. The primary aim is to allow the computer learns automatically without the human intervention. So this is the machine learning process. We have a training data. Then they train doing the algorithm. Then they come up with model and they come up with the machine learning. So this is the input data. For example, you have a training data. Later, the slide there is a example. So you evaluate whether it's a good or bad. This is the one. This is supervised data. For example, this is what there is another data from here. You have a 70% and 30%. You already train your data, training data set. Then you put another 30% inside the algorithm. They can process, they can be classified. So do you understand the machine algorithm? Okay, ka? Sorry, so sometimes I assume the student understand. Okay, go back here. Training data, for example, you have a pear, just now, pear, apple, and also the grapes. You have the training data. That means the training data, for example, you have a 70. Oh, sorry. Sorry, my computer something wrong. Okay, for example, here you have a grape, apple, for example, you have apple, pear, grapes, pear, apple, grapes. That means you have around 70%. That means you have around 100 pear, apple, and grapes. But so it's around 100. You have it. So you have to divide between the training set and the input set. So there is a 70% the training set and 30% the input set. Everything you have a pear, apple, and grapes. So you train your data first. You need to train your data because after you train your data, you come up with the, for example, you use a decision tree. The algorithm decision tree to classify it, which is apple, which is the grapes, everything. Then you come up with the model. Later, after that, you run another 30%. So your algorithm already understand what is pear, what is apple, what is the grapes. So then another 30% they run, they classify it, what is apple, pear, apple, and grapes. This is the one, whether it's a good or bad. If your algorithm come up with around 60% classifier, is not a good algorithm. Because later on when you run the input data, it might be worse because of your training data is not classified properly. So this is the reason why you have a training data and the input data, so that your model understand what is pear, apple, and grapes. So this is the one that I explained. This is the one that I explained. So it's under the supervised learning. This is the algorithm. This is what the algorithm is important to know. Once you use a wrong algorithm, we will come up with a wrong output. Okay, the another one is a machine learning. Another one is machine learning is unsupervised learning. Which is unsupervised learning, they only put all the raw data and the algorithm, they try to classify it. One of the algorithm unsupervised is the k-mean. The one algorithm that supervised is a k-mean algorithm. So this is the data unlabeled and unsorted, similarity and the difference. So the algorithm will classify it because they have no history of the data. So this is supervised, the difference between the supervised and unsupervised. That's why when you are machine learning, the basic things, machine learning, machine learning, there is a two, supervised and unsupervised. This is unsupervised data that we run it totally. They do a classification. So after you are correctly classification, that's why they have around 60%, 90%, 30%. This is the output of the percentage. What are the data mining? Data mining is firstly, you have to do a data cleaning. You make sure your data is clean. Understand about your data. Then is there any data that you need to integrate? Yes or no? If no, then you can skip. For example, sometimes the data integration, maybe you have a few worksheet that you need to combine it. You need to integrate it. So selection of data, remember, you need to know your attributes. What is attributes? This is your attributes. What are the name of the represent of your data? ID, first number, last number, client, what are represent your data? So the lastly, we need to transform the data. If not required, then it's okay. Then if required, you need to organize it, or you need sometimes in the WEKA later I will show you. Maybe from the numeric, you need to change to the nominal. Later in WEKA, there is items that you can change your data from the nominal, which is the we have a decimal point, to a numeric 0 to 1. This is the one. And the lastly, you are using the data mining, WEKA, then knowledge representation. What are the output? So data mining, is one of the application is WEKA. I think there is a few. WEKA is quite famous lah on the data mining. Inside the WEKA also there is a machine learning. That's why machine learning is a part of the data mining. Actually, data mining and machine learning is related. That's why sometimes even me also confuse data mining, machine learning, because they are sharing the algorithm also. Okay, data mining process. Understand the business. Okay, recently, last year, I did one project using a WEKA. For example, in the banking, they want to know whether the customer can give a loan or not. It's more on the prediction. That's why I have a lot of data of the customer. Then there is a remark whether this customer is paying the loan on time or not. So if the customer can pay every time, is a very good customer. If the customer, for example, 1 month pay, second month no, third month pay, fourth month no, this is not it's not a good customer. So I predict that actually the decision that the banking is doing to giving loan is not a good judgment, because it's a lot of bad customer rather than a good customer. Yeah, I run in using the WEKA. Like I mentioned earlier, I only run the WEKA to know what are the algorithm. Then we are developing using the Python. So the WEKA is helping us more faster to determine what are the algorithm. It's fixed. So preparing a data, the data clean, any missing data, I need to ignore it. So you need understand about the data, like I mentioned earlier, what are the attributes, prepare the data, make sure your data is clean. For example, like when I receive the banking data, the data is very massive, which is sometimes the age is missing. The sector is the person working, whether it's a government or anything, it's been missing. So when you receive the data, if you know that the data is very important, you have to go back to the banking, because the banking have a application. That's mean all the information. Maybe the system is not capture all, but there is a hard copy. So when you receive the data, if the data is something missing data, do you need to ignore it? If there is the data is not important, yes, you can ignore it. But if the data is very important for your execution of the results, you need to go back to your user and find out what is the data. So another one is build the model using WEKA and evaluate the result. What are the outcome? Oh, actually be a bit fast. Have you all installed the WEKA? Have everyone installed the WEKA? Yes. Okay, understand about the WEKA. Pre-processing data, visualization of data, understand the test options, classifier. This is the classifier that we will sharing. The normal one, 1R, rules, decision tree, nearest neighbor, linear regression, multi-layer perceptron. What I did on my PhD is a multi-layer perceptron. What I did on the banking is more, I cannot remember, I think the nearest neighborhood. Oh, a decision tree. Recently, I did my student is doing the decision tree. So this is all the famous algorithm. So understand, before you use WEKA, you need to understand what is WEKA. WEKA process data, it's not actually, what is WEKA? Why WEKA? WEKA software download and data format in the WEKA. So are you sure the WEKA data you write in the WEKA, you come up with the result and you happy? Is this the WEKA is doing? Is this the WEKA is doing? Anyone can answer? Halim, since you are a student. We're sorry, because I only saw your name in front. Do you think make you happy once you have a data, you run WEKA and you come up with the result?
I think yes.
No. No. Because WEKA is only helping you. It's not. You need, once you use the WEKA, you need to know what are the best, what are the algorithm, what are the best algorithm, what you call it? The description that you need to change. What are the item? So no, WEKA is not just you got the data, you run, and you come up with the results. When I, as a lecturer, I'm now the lecturer. So when you have a papers, if you have a data, you run WEKA, you come up with a result, you won't go, you cannot go very impact paper. Like for example, Scopus, as Scopus you can go, but not on the web of science. So WEKA is only helping you. When you have there is a difficult to get a very good journal when using a WEKA. But you can go for a Scopus or conference Scopus. Okay, this is the one just now. Same thing, process data, ask the question, what do you want to know? The objective, what you want to know the results, gather the information, whether it's nominal, ordinal, discrete, or continuous, clean out the data, define the features, deploy the results. So I repeated this 3 times. It shows that it's very important, especially the type of data. Because when you have a type of the data, not, for example, like, I cannot remember, nominal, I think, cannot be run by linear regression. So that's why sometimes when you click, you upload the data, sometimes it's not been, you cannot click. You cannot, for example, like, later on we have, later on we will show. So WEKA. WEKA is a data mining developed by the University of Hokkaido. What are the WEKA name? Hokkaido Environment of Knowledge Analysis. WEKA can apply data mining models, cover all the major machine learning algorithms. That's why I mentioned that this is data mining. Inside the data mining is a machine learning. Some of the paper, some of the description mentioned that data mining more on the unsupervised, machine learning on the supervised. But actually machine learning inside, because machine learning cannot work without the cleaning of the data. So tools that pre-processing and visualization data. One thing about WEKA, you do not require the coding implementation. So this is a good about WEKA. You don't have to do a coding. So this is the bird. So the WEKA is also known as a Maori, hence wooden and lightless bird species of the rare from the New Zealand. I never been to New Zealand, maybe one day. One of my target to visit New Zealand. If you can see, I don't know, do you remember one of the story, Lord of the Rings? So Lord of the Rings, the location of the Lord of the Rings in New Zealand. I think in the southern of the New Zealand. But I'm not sure the Hobbit. I think the Hobbit village, whether it still exists or not, I'm not sure. But I visit Indonesia. There is a Hobbit village somewhere in the Yogyakarta. There is a Hobbit. Hobbits, the location. Do you know the Hobbits? If you see the Lord of the Rings, you know the Hobbits. The small guy. What in Malaysia call it is a kedil. Orang kedil. I don't know about Indonesia. Is that the same meaning? Kedil?
Yes, same.
Yes, yes.
Yeah, there is a Hobbit's house. That is why this is the very bird from only in New Zealand. That's why they name it as a WEKA. It's not as a Maori hens. This is the history about the WEKA, developed by University of Hokkaido. Okay, why WEKA? Easy to learn, free and open source, easy to run, and runs in many platforms. Do not require any programming knowledge, but need to understand the classifier, decision tree, linear regression, and multi-layer perceptron. So why the people are using WEKA? So this advantage is not flexible in the programming base. If you are a programmer, it's more flexible and writing codes do not supporting by WEKA. So me personally, I prefer the programming. Because when you run a programming, you can enhance it. For example, like when you do a decision tree, I touch a little bit a decision tree. In the decision tree, you have entropy. The algorithm in the decision tree. Because the entropy is designed, make a decision whether you can go to the left or you can go to the right. Left here, left or right, and this is the one, left or right. This is the reason why I prefer the coding, because the entropy, we can do it. But when you are run a WEKA, it's already, they come up with their own entropy. You can, later on, you need to customize whether you want 1 leaf or 2 leaf or 3 leaf. But if you do a coding using the entropy, how many leaf is based on your entropy. So most of my, currently most of my research, I do the decision tree. Okay, WEKA is a software, data mining software written in Java, distributed under GNU, used for research, education, and application. So main features, comprehensive set of data pre-processing tool, learning algorithm, evaluation methods, multiple interface do not require, and experimenter can compare with a learning algorithm. Okay, have you download? There is many slides you can show. This is one of the YouTube, and also you can go to Hokkaido, New Zealand. There is a book you can download, WEKA book. Sorry, this one. So it's very thick. So you also can run on the major WEKA, can run a major free and easy platform, and this is the documentation of the WEKA. Okay, the file format WEKA is different, yeah, from others. Like for example, programming, Python, everything you can run using the exe or text. So usually Excel. So in Python or C, you can run any extension. But in WEKA, you have to convert into the ARFF. When I first time using a WEKA is around 10 years ago. When I did my PhD around 2000, my Viva is 2012. That's mean I run my experiment is 2012. I did my last experiment. So my experience when you to convert to ARFF, I convert it a few times. Because sometimes when I convert, it's not working, it's not comply with the WEKA. So ARF, attributes relation file format, WEKA ARF files include a two main part, specific of the features and actual data. Files of flat files usually a common separate. Okay, this is the one. When you see in the ARFF, there is a commented. Commented in the ARFF. This is all the commented that explain. This is something like we call it in the programming declaration. Do you know that in the programming you have to declare whether what are the attributes? This is the one, attributes. Or this is the relation, the file. This is the attributes. This is one of the diabetes data, I think. Then this is how you categorize. And you have to know, when you create, this is the data. You have to be careful when you create the ARFF. Make sure that H is this one, the column H, monopause, tumor. You know the tumor, the involves not everything you have to be same. Female, breast equal, irritate, and the classes. So everything you have to reflect with the attributes in the same column, same, everything is same. But when you start the data, you have to put here, data. This is my PhD data. This is the one, instances, number. So there is a prediction, this is the one, prediction. This is the class. Instances, sorry, instance is 0, 1, 2, 3, 4. Instances number, then prediction, whether what are the subtypes of the leukemia cell, the classes, and this is the, when you have a numeric data, you don't have a range, like here, you have a range. You know what are the types. This is more on the nominal thing. Yeah, this is more on the nominal data. The cancer data is more on the nominal data. But my data is more on the qualitative data. This is the one, qualitative data. Because there is a decimal number. That's why you can create it as a numeric. This means there is no range. So this is the example of the data. You have to know your relation, your attributes, and before, after you define, start the data, you have to make sure that add data. This is the one, add data. Okay, to start, run the WEKA, you have to use the console. This is the console. So this is the one that we find focus. More focus, because since we have one day, explore enables you to apply the multiple actions, but does not explicit model them. Then the another one, this is the one, you have the explore, experimental, knowledge flow, benchmark, and the simple clicks. Experimental, run many experiment, control, I never tried this. I only trust the explorer. Like explorer, but each step is represent a node of graph. Benchmark combined with UI and simple command line interface. Maybe if you have time, you can use the books and study more. And maybe if you have used any of them, maybe you can share it with us. Okay, pre-processing data. How to import the data? Pre-processing filter. It is strongly recommended that you install the notebook. Produce each step on your notebook. Have you installed? Have anyone installed? Okay. Okay. So first one is click on the Explorer, processing. So input the data. So you have to remember your data is ARFN and CRV. I never use C4.5, but I use the CSV. Converted the data to WEKA, pre-process, open file or open URL, and you have to know your default is ARFF. So the folder, in the folder WEKA, there is a folder data. There is a lot of data. Later we will use that data. Move the data to any item that convince you for you to access. For me, I move to the desktop, but it is up to you all. Later, we will use a lot of the data inside the folder.
Berapa ini?
So you choose the breast cancer
Right.
and the 3J48 is one of the decision tree method. Okay, this is the one, breast cancer ARF. Open file, choose the breast cancer, classifier, choose J48 and you run. Okay, can we start together? Well, I need to share, is it? You share. Can you see the WEKA?
Yes. Yes.
Okay. So we start together. Choose the breast cancer. That's the WEKA. Explore. Open file. For me, I put here. So have you find your data in the WEKA folder? Can you see this part? Can you see WEKA? No.
Yeah, we can see the WEKA interface.
How about the open file?
We can't see the other application that you open.
Okay.
We only see the QI of WEKA.
Oh, okay. Okay. Have you seen? Can you see all the screen?
Yes. Yes.
Okay, I share all the screen. Okay. So firstly, you go to close, yes. So you go to WEKA. WEKA. You go to explore. So you open the file. You go to the data inside the WEKA. You click the breast cancer, open. Okay. Do you remember this is all the attributes? This is the one. You go to the open file, breast cancer. Have you choose?
Yes.
Okay. So you have choose. So you go to classifier, you choose what I want the classifier to be J48. J48 is one of the decision tree. So you go choose decision tree J48. Can you go? Have you tried? Choose.
Yes.
Okay, this is the one, the class. Then you start. So from here, the result, there is a correct instances. That means they are correct classified. When I mention about the percentage, sorry. Yeah. When I mentioned that the percentage correctness 75. This is the one, the number of leaf, the size of tree 6. You know the leaf, there is a leaf below it. The what I mentioned here, leaf. I try to do a drawing first. Draw. So what are the leaf? You have the head, the entropy. This is the leaf. So in here, there is a result shows that there is a 4 leaf and the size of tree 6. Leaf, that means the size of tree, I think the level is 6 level. They have a 4 leaf. How they do a classification on the simple. But when you do the J45, J48, you did not know the entropy. The entropy, the header starting, how they define. So that is the one of the rules. Then when you click here, you can change it to you can change the classifier, the minimum object. Maybe we can change to 6. What will happen? So we start again. 74, which is the worst than the 74. So one thing, I think you can refer to the books. What are these mentioned about? The minimum number of objects. So that means it's not just changing, but you need to understand. So the result is getting worse when you do the changes. The list is same and the size is still the same. So this is the one. The change. Called filter. The filter can be used to improve the performance. Okay. Now we can use the pre-processing using the filter, or the filter can improve the performance. Okay. Can you try a few? I give you 5 minutes to try other files. Is that okay? For example, you can go to pre-processing, open the files. What files that you want to use? UPU? Open. When you do the classifier, you can see here, you cannot click. You can click, but you cannot run. This shows that your data is not compatible with that algorithm. You know that the color, if the black, yes, you can click. But if not, you cannot click. Here, voted, but you cannot click because your data. That's the reason you go back to the first that I mentioned, that I explained. The type of data is important to know. Okay? Okay, I give you 5 minutes. Is that okay for you to explore? Okay,
Excuse me, doctor. I think there are some questions from the participants. Some of them have already been answered by the other participants, but I think there are some participants who are still confused on how to insert the data.
Oh, okay.
Yeah. Would you
Pre-processing.
mind if we restart it from the very beginning? Maybe it would be very helpful for some of us.
This is the one. Open file.
Oh, yeah. So we open the file.
Then you choose any. Make sure where is your data, WEKA. Where you install your WEKA. Inside the WEKA,
Oh.
there is a folder of data. So you just search for the data, then you can find. Or you search for WEKA, then inside the installation of WEKA, there is a data.
Okay, okay.
Uh,
Okay.
because for
And
me, like I mentioned earlier, this is the one. After you install the data, I think I mentioned that I moved to this the one. Oh, this the one. Pre-processing filter store recommended that you install WEKA at your notebook. Reproduce the step in your the data. Where I put yeah, just now I mentioned move the data. Oh, this the one. Folder WEKA, have the folder data, move the folder to any which is convenient for you to access. And you have to move, for me, I move the WEKA in the desktop. So what are the data? Okay, ka?
okay, doctor. Thank you. So we have the second question, and this one hasn't been answered. So the question is from Ali Ahmad, and his question is, how do I access that option change classifier from before? So he wants to change the classifier. So how does he do that? Yeah.
For example, you want to change, you just choose.
Oh, yeah.
Change the meaning object. Okay. What I mean, you, for example here, you click. Right. I choose the back. 3. Where's the data? You see, just now I tried to run the data. It's not working for the J48. Classifier. J48. You click here. Click. Ada choose. Okay. Can you find Ali? Ali Ahmad, can you see? Oh, yes. Yeah. So you click at the tab. Okay. So you can play around. Alamak. Kejap ya, Pak Hendra, nanti saya share. Kejap. Desktop. Okay, saya dah share. So can we try? Is that okay, everyone? So you move your WEKA data, which is your convenience to access. Okay. Okay, ke? This is the data that you can see, the data. Open. So when they reach a breast cancer, they give you what are the data all about. From where, post, the data. Relevant information, number of instances. This is all about the data from WEKA. The instances, the attributes. Okay, this is the one. They mentioned they have a lot of the data is around 286. For example, when I did my PhD, the data looks like kenapa? Okay, when I did my PhD data looks like WEKA. Not this one. This is the all the data. Data WEKA. This one you can convert to CRV without the file. This is the one. It's the CRV. But this is the one final data. Sorry, I have to find the real WEKA data. This is one of my WEKA data, my real data. So here you can see the classes, the numeric, the subtypes. This is the data. But I did not mention I have around 648 instances. So this is from the image of the data. This is the one, average low. Have you tried to explore it? This is another type of CRL, CSV. There is a class, average, everything here up. You can do also like this. Have you tried a few? Okay. So I already shared the trainings. Okay, the next one, filter. Pre-processing filter. In WEKA, filter can be used to improve the performance. So you choose the Waidah nominal, ARF, explore, Waidah nominal, open. So the next one, step, click filter. Which is filter? This is the one, the filter. If you can see the slide, filter, this is the one. So you click the filter. Filter, Then you choose unsupervised attributes, remove. You click at the remove. Wish you want to remove the number 3. Okay. Then you apply. Here is missing. Okay. Again, you choose the weather, nominal, add the filter. Is the filter. You choose unsupervised. Because you want to remove the attributes, you have to choose the attributes. Then you click remove. Then here, which index? Index number 3 just now. You also can put undo, yeah? Undo. Click on remove the attributes number 3 and apply. Okay. Here. What do you mean the represent the red and the red and blue? Red, there is a 9 and the weight is the no is the 5. So when you put the outlook 5, 4, 5, it shows that maybe 3 is no. Okay. Red is no. Yeah. Maybe there is a half is no. Half is yes. Number 4 is the blue. Is the yes. So this is the separation of the color. You know, although it's 5, but there is some blues, some yes, some no. The blue one, totally blue, it shows that it's totally yes. The outlook, there is a 3, sunny, overcast, and raining. The temperature, hot, mild, and cold. Humidity, high and normal, windy, and plain. Also, you can remove it by click and remove here. Okay. And you undo. There is 2 types of remove. One you can choose at the filter. Another one you can choose the attributes and click remove. And you also can undo it. Example of the remove the instances. Attributes. Click the attributes and remove it. And now we want to remove the instances. Okay, everyone? Muhammad Ali Ahmad.
On my computer, the attributes to the remove button is grayed out. I can't click it. Is there what?
You remove button is a gray.
It's grayed out. Yes, the button is grayed out. Can't be clicked.
You follow my step again. I choose which file, whether nominal. Whether nominal, open. You choose here. You click at the filter. You click here, unsupervised, attributes.
Remove.
Click remove. Okay.
Still can't be clicked. The humidity can't be clicked. When you click a humidity attribute, I can't click the remove button because it's
You
grayed
can
out.
click here.
No, the one on the bottom.
Bottom here.
Yes.
You have to tick.
Oh, okay. Yeah. Thank you.
Okay. Because if you did not click, they did not know which the items that you want to remove. Okay. Okay. Then you have to remove the instances. So you choose the Waidah nominal again. Open. Then you click choose unsupervised instances. Remove the values. Click on the remove the values. Then you click here. You find there is a index number 3. Nominal index you change to 1. See what happened. Okay. And index number 3 humanity. Line. You see? You change your instances. Instances is inside the count. You remove it, the value. Can you try how to remove the value? You can follow the slide. I already shared the slide. Okay. Here. Why you need to remove? Okay, have you tried? So why you remove? You go back to the normal, where the normal. Classify. You pick the J48. You start. I think I already changed that one. Okay, you go to open file. You go to data. Data. You go to the Waidah nominal. Okay. When you go to classify, you go to J48. Then you start. It's 50-50. J48 nominal. Oh, I think I run the wrong one. Okay. So after you remove, what will happen? Where the nominal? Okay, 50-50. So after you remove the humanity, what will happen? So it's 42. It's even worse. You understand? Sometimes why you remove the data, sometimes the data is not required. So sometimes it's required. You understand why what I mean is why is a remove important? When you run the nominal, first time I run the 68.8, maybe do you get the answer 66.8? Because I run last time, it's got 68. Yeah. Do you get the 68? Hmm, 50-50. Okay, no 50-50. Okay, it's okay. So, once you got the 50-50, I'm not sure, I'm using the different data, I think. So after you remove the data, sometimes it's getting worse and it's getting better. So why you need to remove your data? You understand? Okay. Once you do a remove, once you remove your attributes, maybe you find out that these attributes is not related. The attributes is not related with your result. So you can remove it. So make sure that sometimes you remove, you got a better, sometimes you remove, you're getting worse. So this, when I run, I'm not sure, I cannot remember which data. So when I run, I got the first one is better, it's worse. But when I run the second one, it's better. It shows that the attributes is not related in the algorithm. So whatever you do, you remove, you need to find your justification. Why you remove, why you change to, why you remove, why you change your instances, everything you need to know the justification. What I teach you is how to use the WEKA. So if I want to explain one by one, I think I need to have one course. One course for 14 weeks. So we only have a 1 day to explore it. This is the one. Okay, ka? Then you start. So what you should, I give you 10 minutes, import data to WEKA, remove the attribute, remove the indices, and any types method of the J48, compare it, and before we move to another visualization of the data. Okay, ka? Because the last one is very interesting. I want to show you. Regarding this visualization using the Google Studio. Hopefully we have time to explore it. I just play around with it. Later, you can find like this. How you visualize your data. This is more on the visualization of the data. But later, if we are in the afternoon, we can play around. But can you do this part? Can you do this part? Play around, get familiar before we go of visualization. Okay ke? Okay ke? Okay ke?
Okay,
Is that
Doctor.
okay? Okay, can you try to play around first? Get familiar with the data, see the data. What is your comparison? You see there is a lot of data here. CPU data from the numeric prediction. This is the one. This is the like my data. They declare it as a numeric. Diabetes data. This is original owners. Sometimes the data is being shared. I also share my data in GitHub, I think. That data also I share it. If you want to play around, I have to open my. This is the one. I also share the data on the internet. So you also can share a data. I think there is a lot of data in the GitHub. So you can go to this paper so you can play around with the data that I share. The data set. This is one of the data that I already share with the online. This is the one. This is the one. The data. The data that I show you just now, this is also the data you can download. There is another paper also. This also we have the data also. This is the one. This is of the data of movement. So there is a lot of data inside the internet that you can explore using the WEKA. You can view the then the data is open access skeleton. Sometimes I review the paper also that have the online data. Okay, ke? Have you explored? This is the one of the paper. Have you tested? We have a lot of paper together, Pak Hendra.
Yes,
but this year I'm a bit slow.
it's okay.
I sent the paper, but I don't know, it's getting rejected. I don't know why. So I have to send another one, keep sending lah.
Okay.
Inshallah. So, hey, have you tried? I just Google it my name to see my index. I thought we already got 2 papers conference, WOS I think, but it's not still put inside the Scopus.
Oh, okay.
There is 2 paper. And one still under review, Q1. Another one is got rejected. I need to restructure back.
Thank you.
This is the one, the paper still under press. I don't know why. Article in press, but it's already published. Yeah, if you have any question, you have to raise. Okay. Okay, everyone. So this is a few of the data. Okay, can we continue the visualization of the data?
Yes.
So inside the visualization of the data, we can use the iris data, click visualize, there is a spectral Y and I, and outcome the click instances, come out with the instances information, get jitter at the randomness as in Y. Double click in the instances and shows the instances. So here, the visualization, one thing good, they can visualize your data, and when you click the data, it shows what are the instances is not fit. Okay, explore. So we use which data? Iris data. Iris is eye, mata. Iris data. Then you click the visualize. So for visualize, you click the sepal width and pedal width. Visualize. Then come out here. You can click pedal width and pedal width. So here you can change also. Pedal width and pedal width, is it? Pedal and pedal width. Pedal width and pedal width. So you can see here, the blue one is iris sentosa, iris vesicular, and iris virginica. So this is how they plotting the data, X and Y. The color represent the plotting. So you want to know, you just click one of the, click here, it come out. The instances number 71, and also the 128. What are the color? Iris vesica and iris virginica. Although you can see one actually is 2. This is 1. So can you play around? What are the data? This is when you visualize, it shows that what are the data type. What are the instances? Okay, ka? Okay ke? Okay. Is there any problem? Ada problem tak?
Terlalu cepat, Bu.
Cepat ke?
Iya.
Slow. Okay, you click again, you get the iris data, keep visualize. This is the visualize. Classify, processing. We go to process, classify, and visualize. This is the one. So when you click the visualize, you can pick here your X and Y. This is the step. So you can drag the jitter, add the randomness into the X and Y. So here also, you can play around with the jitter. They can random it, the data. If you can jitter here, you can see a lot of the data you can see here. It's around 3 or 4. Okay ke? Plotting. Although you can see here, it's a lot of data, but you can here select instances rectangle. You select it, you submit. They just focus in that area. You understand? Reset. You go back to the rectangle. You go here, you submit. They just focus to the area. They focus in the area. Okay. Okay ke? This is the one. You can select the area. Which are the area that you are interested with? This is the one. Then you can click which you understand the outliers. This is the one. For example, you can see the plotting. Okay ke? Everyone okay? Rectangle and you drag. The next one, you can go to the J48. Classifier, J48. Here, right click, you can go to the classification tree. This is a tree. And this is the classifier error. This is the error. 1, they list out. 2, 3. Usually we do not know what are the error. It shows that there is a error. When you click on the, they got a 96%, 4 is instances incorrectly, 4%. around 6 instances. So you go to the tree, right click, classifier, errors. You click here, you click here, and you click here. So you can see 1, 2, 3, 4, 5. Another one here, I think. So this is the one. So you understand, that's mean, although you run in the tree only, you can have the visualize of the tree. This is the one, the entropy, they choose the petal width, the iris, petal length, iris virginia, iris virginica, and versicolor. Okay, ka? This is classification error that you can click, you can know. So some of them is very good using the WEKA because it's fast, make you fast. Okay, once you mention that here is 96. So you know that this data is really good for the decision tree. So you can do the coding. You know, you can do your programming using your decision tree items. Another part, usually I see the ROC area. ROC area is nearly to 1, which is good. The curve of area is nearly to 1. It shows that it's good. Another part it shows here. A is the iris sentosa. Wait, I cannot color. Annotation. So here, A46 is iris, B48 7 is iris vesicle, and C is the iris virginia. It shows that 3 is wrong classified. They classify as iris, but actually it's not. And 2, they actually justify on the virginica, but actually it's not. And 1, they classify as the iris sentosa, but actually it's the B. So you can see here. So it's something like A, B, C is something like here. A, B, C. Okay, understand how to read the confusion matrix. Here, A, B, C represent here. That's why the classification is 96%. So ROC is nearly to 1, which is good. This is the classification part there. Okay. This is the one. Cluster. So when I did my PhD, usually my supervisor teach me how to look into the ROC part and also the confusion matrix. It is very important for the classification. Confusion matrix, there is a calculation also. You can find in the internet. There is a TP, true positive, true positive, true negative, true false negative, true negative, and the false negative false false negative. There is a 4 types. I'm not sure whether you already learned your coefficient matrix. Dah belajar dapat Hendra dorang? Mereka dah belajar dah Coefficient matrix.
Sebagian saja. Kalau new student not yet.
Oh, okay. But later on, it's good. Although you're not yet, at least you remember that what is the coefficient matrix is very important. I cannot remember true, positive, false, positive here. Then this is true, negative, false, negative, coefficient matrix. So it shows that 49% is classified correctly, but 1 is wrong. 47 is correctly, 3 is wrong. 48 is correctly, 2 is wrong. Okay, so we have a break 10:30 to 10:45 before I continue on the visualize. This is the one, test option. It's quite important, the test option. Okay, kah? Break. Okay, kah, break? Okay. See you all another 50 minutes. So in meantime, you can refresh lah, play around.
Okay, thank you, Dr. Ladies and gentlemen, as Dr. Waidah already said to you all, I think we're gonna have 15 minutes break. So you can use the time to, loosen up a bit. You can go to the restroom or maybe have some cup of tea, cup of coffee, whatever you like. Maybe take some snacks too, or maybe you can try and explore more in the WEKA. You can do whatever you like. I think we're gonna be back in 15 minutes. And while we're waiting, we're gonna prepare some entertainment for you all. So please be back in 15 minutes. That means we're gonna be here again in 10:45. So see you in 10:45.
Okay, now we continue on the test option. So you also can look in the slide lah. So the understand on the test option. So when I mentioned earlier, there is a training data just now, machine learning, and also your classifier. So usually in a common, always, there will be a different data between the training data and the test data. Why? Because the training data, like I mentioned earlier, there is an apple, grapes, and pear. There is considered as a training data. But when there is a test data, they have apple, grapes, and pear. He knows how to recognize it because he already learned before. They need a different data. For example, when I did my research on the rehab, this patient already have in the rehab, there is a game. For example, the game, they have a low, high, medium. When the patient, we already have trained the data. So we have a train. So when a new patient come in with a test data, they already know that this patient A, we belonging to low. We belonging to high, we belonging to medium. Because what? We already have the training data. So usually the test data and the training data usually people will put as 70% or 90%. The test data is only 30% or 10%. So if you, as a researcher, me as a lecturer, researcher also, when we need to justify, use the training data, we need to know Why we choose 70? Why we choose 90? Same thing with you also. Why you choose 70? Why you choose 90? So the total of the data is 100. So this the one, supply a test data. So inside the WEKA, they can give you supply the test data. So if you open back your WEKA, you go to the explore, you open, find the data, you go to the segment challenge. From here, we know that the data is images. Because if you have original, pixel, density, from the data, you can understand. Like me also, we have a mean, variance, red, blue. So here, they have a classes. So inside the data, they already have class, brick, face, sky, volume, segment, window, and the path and the class. You choose the which class? So here you go to the supplement set. Because you already have a set test data, you go to the segment test. So you go a segment test data, supplement. So you go to Bayes, then you start. 77. So the test data, you can set it. You can set your test data. So once you set a test data, you can go to here, set. There. Set. This is the one. So you can choose your test data. So this is the first one. So you choose the Mavis. This is the results. Okay. This is the test data. Actually, when usually I run the data, usually I run the data using the cross validation. So you can also open segment data again, do the cross validations. More option, you can do a seeded. So in this case, you can choose your open the segment challenge, same thing. Then you use the cross validation, J48. You have to take the J48. Cross validation start. So 95, you click here. You have a seed 1, there is 1 time. So you then change to seed 2. You run again. 95. Oh. So that's the one, you can do a seed. But in this example, I'm not using the segment, sorry, I'm using a diabetes. Okay, before that, I want to explain to you what are the cross validation. Cross validation, you can test, you can 10 floors randomly seeded 2 to 10. That is how you mention the seeded. Later, I will explain more. So in the cross validation, they have a 10 stack. Nine stack, and one is the test data. And this one is the training data. So they do a 10 cross validation. That means the data here, for example, you have around 100, 10 here, 10 here, 10, 10, 10, 10, 10, 10, 10, and 10 here. So this one you have around 90. But although the stack you have a 10 data, but actually they are randomly. They are put randomly, including here. So after they do a randomly for 10 times, they just in and out, in and out, in and out for the 10 times, random. Then the last one, the 11, the data we put here, 10. And here is the 10. The cross validation, when I did my PhD, that means the random data is very good because they put it the 10 times randomly in the stack. So the 11th time, they just put it and run it. There are random verification. So in the cross validation, you open the file. You use the diabetes set. So before that, you need to run your baseline, base accuracy. Base accuracy is a 0. This is the one, the accuracy where I run. Yeah. This is 0R. 0R is considered as baseline. That means if the data below 65 is not a good method, but it's above is a good method. So you run the 10 cross validation using the J48. J48, you start. So you got 73821. But when you run the second time using a seeded, Hmm, 70. Did I change anywhere the seeded or I removed the file? You're supposed to change to here. 34. Wait. Hmm. 32. So you have to change into the 10 seeded. So 10 times. 1, 2, 3 until 10. You run it. So after you run, you have to find the mean. You know why? Because you do a 10 validation. So you want to know the benchmark, the mean of everything. So the mean is 74.5, which is better than the baseline. So any data, you have to run the 0R first to know the baseline. Okay. That's validation 95. And folder confusion 48. Okay. So the next one, you are using the training set. Training set, what I mean is bias because (64). They are using, wait, Margaret, 99 diabetes good. So you got the 94. Training set is a bit biased because they're using the whole data. So you go for a segment challenge. You classify it using the set techniques. You got a 99.1. 99.1 is a bit biased. You know why? Because they don't have a training set and the test set. They only have a training set which is 100%. That's the reason you have a 99. Okay. There's another part is a split set. The split set this is the one you have a second time. Let me run. So the split set, you go to the split set. You choose 90 over the 60. More option. You go to here 2. So if you go to 2, then you start again. We will change to 94. So you can run it until the 10 times. So you got it, the mean. So what do you try? The baseline, the accuracy for diabetes. 0 is 95. You choose the percentage. Split 76, 77, 73, and 74, which is a good because the baseline is 76. Okay, before that, can you all try the 4 options using whatever data? The use tag, the use testing, the supply tax, the cross validation, and the percentage. Can you everyone test? I give you around 20 minutes. Is that okay? Try to understand. Okay, I repeat again. Use testing. Something wrong. Okay. Tak apa. Use testing. They take 100% of your data. They do not have your test data, which is cannot be done. You know why? Because in machine learning, you need to have a test data and training data. But the training data is for the training set is for the training of your data. The second one, supply test data. They have a data, supplies, test. You create a supply test data, which is you can add in. Understand? Cross validation, they have a 10 stack. They randomly go in and out until 10 times. At the 11 times, they stop. That means you have a random of 90 stack, 9 stack, and 1 is the test data. Percentage split is what I mentioned earlier, like it's a 70-30. Go back here. Training data in the WEKA, they have a 4 option. They have a 4 option. One of the option is the training data, 100%, which is this concept. This the one, they have a different data, which is they call it a supplement data, which you can have a different data. This the data, they have a 1 set, they have a 2 option. One is a cross validation. Another one is a split. So this is the features inside the WEKA. So can you test the 4 option with the testing that I show you? That I share the slide. I already shared the slide, is it? Can you do the testing? Can you find the random set? Okay ke? Any problem? Can you test? Okay ke? Can you try? Explore it? I give you 10 minutes, 20 minutes, 10 minutes. Okay. This one shows that the seeded split. Sometimes I also forgot, so I also have to test it. This is the one seeded. 1, 2, 3, 4, 5, 6, 7, 8 times, 10 times. Because when you show the seeded, you change the seeded 1, 2, 3, 4, 5, the result is more accurate. Why? Because you run it for the 10 times and you got the mean. Okay, ke? Percentage split, same thing. Can you try until the slide 120? Okay, ke? Can you try the slide until 120? Can you get the same result as me? On the training set, the training set are the benchmark. The baseline. Okay. One thing, the baseline, usually they run a 0R to know the benchmark of the percentage. So usually you are using the training set because it's 100% of the data. So you need to know your baseline. Okay, what you understand about baseline? Baseline is the benchmarking. That means is benchmarking is, for example here, the example 65%. So whatever 65% above, it shows that your result is good. That means the data is significant. Whatever the 65% below, it shows that your result is not significant. That's the reason why you need to run the baseline, the training set 100%. Gives the result. So you try everything here and also here. Understand tak? Faham tak? Tengok semua macam blur je. Tengok blur je semua. Faham ke? Understand tak?
Faham sikit je.
Cuba buat as you cuba have to play around. Okay ke sampai slide 20? Sampai slide 20.
How to choose the baseline, Doctor?
The baseline, you have to use the 0R. 0R.
0R.
But you have to use 100% training set. Because you cannot use the test data kan, sebab you nak tahu baseline dia. Okay ke Pak Hendra?
So we are using 0R rules.
Yes. 0R rules tu memang dalam WEKA is a benchmark punya. Baseline. Benchmark. So but you have to use 100% training set tau. Because you ambil the whole data. Yeah. Okay, okay, if you want to know what is the 0R punya reason, you click here, you go more, then you explain. Zero classifier predict the So this is the explanation about the 0R.
Sure. Maybe any others rules?
For the benchmark is 0R, but the 0R rules under 0R. That is the benchmark. But you have to use the use training set. You don't have you cannot split because you want to know the benchmark. But for others, you can test on the 4JR or the rules 1R. Okay. Jom kita buat together Again. Test data challenge. Okay. There is a supply data. So firstly, mula. So pre-processing, you open the segmentation challenge. Okay, before that, you want to know the benchmark data. You go to diabetes, classifier, you choose the 0R. Start. 65.1. This is the benchmark data for the diabetes. 65. This is the benchmark. But if you want to use, because the data testing, we have the challenge and challenge test. So you open the challenge, segment challenge. You go to classifier. You choose the test set. You open the file, segment test. Open. You choose, is that already open? Segment test. Okay. Close. So you choose the J48 because J48 is a decision tree, is the simple algorithm. So you got 96.17. So another part, you can test the cross validation for the 10 times. You start 95.3. But the cross validation, like I mentioned, there is a 10 stack. One is the test data, 9 is the training data, that there is a randomly. So you need to test 10 times to make it a very accurate. So this is the split for one time, split for the second time. When you run, they come out is different. You split for the third time. $95. So every time you split, for the 10 times, it come out a different classifier. But you need to know the mean. Because they run 10 times, you need to know more accurate, you have to find the mean. That means you add in and divide by 10. So here you move it, split. Another part, you can play around with the split option, 90%. So 90% you start run, 94.8. This is the third. So if you move to one split, you start 96. So when you do a split also, you can do the 10 times, you find the mean. So it shows that you want to find the classifier is more on accuracy, more accurate. Okay, can you try run with the data? Understand ke? Pak Hendra?
Sikit-sikit.
So because when you do a classification, you need to have this test option. But for me, usually I run the cross validation. Okay, one thing about WEKA, after you start, you have to close there sebab they will take your option tu you dah set. Nanti dia akan lari. So it's better for you to close tu sebab usually saya close. Then saya open a new one. Kalau tidak nanti data you lari. Your data, your results nanti. So you can test from the 93 until 120. Okay ke? Siapa dah run? So conclusion, you have to look at the data set, not blindly apply, understand what is going on. So understand what is going on, benchmark. What are the test option? So boleh tak? Ada yang dah run? Is anyone already run? Or you already lost?
Already lost.
Okay. Which part that you lost? Cross validation or the benchmark?
I think at benchmark.
Benchmark, okay. The benchmarking. Okay. Benchmarking, for example, you lose the diabetes data. Okay.
Then go to classifier.
So you go to classifier, you click 0 because this is the algorithm inside the WEKA for a benchmark, but you have to use the training set. Why? Because you are using the whole data. The whole data. You cannot split your file because we want to know the benchmark of that data. So you start with a, then you start.
Okay.
65.1. So after that, after you got 65, you already know what is your benchmark. So you try to go another method, another model, J48. But J48, you cannot use the training set because it's biased. Because currently you want to test the real data, which is you need to have a training set and a test set. So in this case, you try to use a split. You start. So it's 76. It shows that 76 is better than the benchmark. Okay, understand that part?
Yeah.
Same thing. Or same things, if you choose another method, Bayes. Navy Bayes. Split also, same. 77% here. Then you try lazy. Lazy is nearest neighborhood. This the one, neighborhood search. You use a equidistant distance. Then you start. 72.7 is 73. So another part, you use park. It's under rules. It's park. So you test 74. So it shows that the data is a significance. Result is a significance. But can you show another data? So another data, pre-processing, open file, supermarket. Open. So you have a supermarket data. So you use a classifier. You try to the rules 0R. but you have to use a training set. Then you test 63.
Oh, 64.
64, yeah. 63, 64. Then after that, you choose any, for example, you use a rules also, but you want to use a split set, you start 62. But you use a split set. Just now it's a training set, the whole data. But now you want to use a benchmark, but you have to spread. This means you have a test data, you have a training data. Understand the concept, the first concept. You need to have a training data and the test data. So it come out 62. Why do you count? Why do you join a test 48 again? Then you start 62. 62 point something is 63. So it shows that this is the one split. The result below baseline attributes is not informative. So that is the basic things when you run a WEKA. Okay ke Pak Hendra?
Okay.
Okay. How about others? Okay ke?
Okay, Doctor. Thank you.
Okay. You all tak lost kan?
Nah, sudah.
So remember that in machine learning, you need to have test data and also the testing data and the test data, training data and the test data. So again, I move back to the earlier slide. This is the one. Supervised and the unsupervised, which is the input raw. This is the one, sorry. This is the one. Again, you have a training data, you train, you have a model, you have input. But for the 0R, you only use a training data because you want to know the benchmark. You don't have to use the test data, input data. Okay ke? Faham ke?
Insyaallah.
Okay, can you try play around sekejap? Before the news, move another one is more harder. So you try to get it 10 times. 1, 2, 3, 4, 5, 6, the split. Where is the split times? Split, you go to more option. This is the one. Seeded rank 1, split 1 time, second time, 2 times, 3 times. The classifier is more harder because it's start doing the algorithm. So before we start the algorithm, you understand about the test option. Student okay ke? Okay ke student?
Sorry, Doctor. So what is the difference when we inputting different random seed number? Is it the result?
Yes, the result will be different. That's why I asked you to try. The result will be different, something like this. Once you run, why are you need to run the 10 times? Because to find a more accurate. based on the benchmark, more accurate percentage. Based on the, you did not see the baseline also okay. Because it's 90, 97, we know that it's a very good classifier. So the accuracy is between the 96 and 97. Say, when you did, maybe I'm not sure about Unai, maybe in the degree also. Once if I think I did the examiner, one of the Universiti Islam Indonesia. Once the examiner will ask why your justification only 0.967, but you did not have a test enough. So you need to have a good testing to justify your results. The examiner will say that only you run a one time. Are you sure? But you need to do a very good justification. When you run the 10 times, you got a mean. Then it shows that your result is more accurate. Okay ke? Faham tak?
Okay, doctor. Thank you.
You can start right. Before I go to the classifier, it's more harder. Just see when there is a tree, you just show the trees. Classifier errors. Which are the errors? How's COVID in Indonesia, Pak Hendra? COVID. COVID in Indonesia, how is it? Is it getting better?
Hobbits.
Yeah. COVID. COVID.
Oh, COVID. Decrease significantly.
Decrease.
Yes.
Oh, okay. In Malaysia, it's something like yo-yo.
Yo-yo.
Sometimes down, sometimes up. Then down,
Oh.
up.
No, but in Indonesia, it's okay. No worry about the COVID.
Are you still wearing mask?
Not very much. Maybe in
Mask.
Jakarta. In Jakarta, just in Jakarta, significant. But not very much infected of COVID. Because so many Indonesian people got booster.
Booster.
Yeah.
Do you get the third dose or fourth?
Still 3. not fourth. Not yet. Fourth.
You know what? I got the first one is okay. I got a fever. The second one is getting worse. I got more fever.
No.
The third one is even worse.
Oh, even worse.
The fever is getting, and I have difficult to snitch, bersin.
Oh.
Saya susah sangat nak bersin. Dulu saya selalu bersin tau, kerap dah juga. Tapi bila sekarang ni tak macam susah nak bersin. So bila bersin sini sakit, sini semua sakit.
Oh.
Bersin tak lepas kan?
Yeah.
So the fourth one I don't think so I want to take.
Kalau saya tidak apa-apa. Tak masalah.
Oh. Wah, antibody kuat.
Oh, bukan begitu karena jenis vaksinnya sama.
Sama.
The same vaksin.
Pfizer.
Oh no Pfizer.
Sinovac.
Yes, Sinovac 3 times.
My one is Pfizer 3 times. Oh, tak sanggup dah. How about the student already got the vaccine?
Gimana Halim? Halim enggak.
Tak ada dah Halim.
All UNER students already got twice of vaccine already, but maybe not all got booster.
How about the class already face to face?
Yes, no problem. Gimana Halim kalau di kampus katanya? Udah
Pak Hendra di mana? Pak Hendra bukan di kampus.
Tak, di rumah ini. Di rumah semua ini. Gimana Mas Halim?
Oh yeah, I think for our daily activities in campus, I think most of us still wears mask, but it's not that, it's not that necessary, because sometimes we often interact without mask because in like a safer place. So it's not like we are abandoning the rules of using mask or washing our hands, using hand sanitizer and all of that. But I think it's more of having the belief, because we already have the third vaccine, the third dose. Somehow I personally feel like I think I'm stronger than I used to when COVID is still like in high numbers. So we're doing pretty well in daily activities in campus. So yeah, and most of our classes are already offline. It's very rarely we met at the Zoom. Only when we have, only when one of our lecturers maybe
Not feeling well.
he or she is not feeling well, then we will have a Zoom class. But mostly we're doing face-to-face class right now.
Oh, you already start the face-to-face class.
Yes, yes.
Oh. From in Malaysia, we still online, but we will start face-to-face next year. The next semester, I think around October, we start the semester. We start teaching face-to-face.
Oh, I see, I see.
So last semester, the student still doing the exam online.
Oh, yeah.
So when the marking the exam paper, mostly I can see the text inside the internet. You know, the text mostly in the internet. So when I run the turning in the paragraph, it seems like around 90% is similar. 70, so we understood. So the next semester, mostly, almost all lah, will be do the face-to-face.
Yeah.
Okay.
Yeah.
So your examination last semester is online or offline?
Last semester,
Last semester?
I think it was offline,
No.
right? No. It was online.
It's online.
Semester 6. The sixth semester was online. We
Semester six.
started the offline sessions in this semester, which is 7th semester. And now we're in the midterm test.
Oh,
This coming week, yeah. The midterm test is also offline. So this semester we are doing it fully offline.
okay.
It's
So-
a pretty huge change from the last semester to this one.
So Pak Hendra, you can give the question based on the WEKA also for all these students. Because they are waiting for the mid test. So you can give them the the exam paper, mid test paper.
Yes.
Okay, we continue with the classifier. So the classifier is a bit tough. That's why you already know the option. So the classifier is more related with the method. So there is no best algorithm in WEKA, but you need to understand the attributes. For example, one attribute does all work. Attributes contribute to equally and dependent. So firstly, we test on the decision tree. So decision tree is the top, you divided, you conquer. You divided, you conquer. That means there is a selector of the root node, create branch of each possible attribute, split the instances into the sub. One of the branch extended the node, exclusion of the, that means they are repeating again and again and again, and only instances that reach the branch. And lastly, stop the instances. So in the decision tree is lately is my area that I explore, which is I love decision tree. It's a simple algorithm. So in the algorithm, okay. So in the algorithm is something like I mentioned, this is the entropy. The decision tree is good for the clean data. Clean data. The data is already clean and we know what we want to find. The attributes already know. The decision tree is good for a decision making. So if you want to do your final year project, final year project, or your master or your PhD, decision tree usually is related with a making decision or suggestion. Because they have a, I try to remove the, mana? Why I mentioned that decision tree is good for the decision making? Because they have an entropy. So for example, you want to know the improvement of the student. This is yes, this is no, and this is the result of their exam paper database. So this is maybe on the paper on the telecommunication. Yes, no. So this is maybe on the telecom, this is maybe on the networking. So from here we can see that the student is lacking on the networking at which topic. So because they have branches, yes and no, yes and no. This is more decision tree, is more slightly on the decision making or suggestion. So this is the classifier of decision tree. So before you use the WEKA, you got to know what are the method. It's easier. So decision tree usually is the 48. So you can try. For here classifier, I a bit slow because it's really involved the method. So you run J40 and with division tree. This is the reason. The outlook, sunny, humidity, high or low? This is the one. So you go to the classification error, you can click and you can find the error. Okay, can you try? I give you 5 minutes. Test first. This is the one. Weather, decision tree, and the a few tests. Okay ke student? Sampai slide 130. Okay ke? Semua dah ke? So you can play around with the classifiers. Cuba try to use the 4 split. Use training, supplier test, cross validation, and split. Percentage split. And try to see the visualization tree. Okay ke? So kita continue on the pruning tree. Pruning tree don't continue splitting if the nodes get very small. So kalau dia jadi very small, so we don't have to continue splitting. So build a full tree, then work back from the leaf, applying the statistical tag of each. So sometimes it's good to prune an interior node, raising the sub tree. Benefit is up one level. So dalam J48 is popular early machine learning methods. Many different pruning methods. Prune tree, size of the tree. Pruning is a general technique that can apply to structure others than a decision, other than tree decision rows. So what do you try? Diabetes, 48 decision tree. 3 under tree, 48. Then change the prune to false. So you can see the by default is 20. But when you turn off the prune, become the leaf because a 22. So can you task this one? So the J48 is popular early on the machine. So different pruning method is a change the size of the prune tree. The reason is don't continue splitting if the nodes are very small. So in the WEKA, we have the pruning method. So you change the prune to true. under unprune to true. Then you test all this data. Diabetes, J, change to false. So if you change the by default first, you run by default first, do you get the 20? But when you turn off, you got 22. And also try the cancel. Sometimes it's by default, it's better. Whatever in WEKA, for my experience, when I do the WEKA, whatever they have by default is better. You understand? When you are by default, that is the best. So usually I do not change, but you can try to play around. So here, prune. You change the prune to true. How you get this menu? You click here. You click at the method, the classifier. You click here. Okay, can we try the diabetes data? Explorer. Diabetes data. Open. You go to the classifier 48. 3 is a simple decision tree. This is the proof false. So you start. 73. How many leaves? 20, and the size tree is 39. So when you change the prune to true, okay, then you run again. You got a 72, but the leaf is 22, and the size of tree is 40. This is how you separate it. Unpruned tree. So you can see the headers, the entropy is 1 to 7, how they divide. So also it's difficult to see, you can see the visualization tree. This is how the tree looks like. And this is how you can see the classification errors. There is a lot of errors. So that's the one. So after that, you try also, there is the diabetes data. So the next one, you have a breast cancer data. Breast cancer, open, classifier. Just now you true, you go back to the false. Okay, you start. 75. When you still continue, if you change any variable without closing the WEKA, they capture whatever changes you have. For example, just now, remember when I change here to prune to true, when I run, they still accept the true one. So if you don't want to, if you change a lot, you better close and open it again. So you change the prune to the true again, then okay. So 69. and the leaf is 152 and 179. So it shows that sometimes prune is better, prune is not. So it shows here the default is a better leaf. Although they want to make it no smaller. So this you understand the prune and the decision tree. This is the method that easy to understand decision tree. Okay, this the one also a easy method. Pak Hendra, student dah dapat slide senyap dah Pak Hendra. This is the nearest neighborhood. Nearest neighborhood is something like the data is spread. This is the data. This is the data. And this is the K. So they need to do the classification. What are the nearest to K? Based on the two type of method. Type of method. One of method that always equilibrium distant. Did they know how to the distance? The equilibrium distance? The second one is Manhattan distance. I think you already learned inside your mathematics. Manhattan distance. So equilibrium distance is you have to know the X and Y. X and Y, there is a divide. X and Y, X and Y. But when use the Manhattan distance, they based on the block. When I did my PhD, I did both equilibrium distance and Manhattan distance. So the nearest neighborhood is based on the nearest distance to this point. What are the nearest distance? This is far. They cannot go to this nearest. They might be go to another K. There is a recent paper. I'm still waiting for acceptance. It's regarding, I'm not sure whether I already share with maybe whoever attend the class regarding the distribution of food during the flight. So that means my master student will find what are the K and how they distribute to the nearest neighbors flight. That's the one, the nearest neighborhood. So this is the one, the K. For example, this is the K. Okay. So what are the nearest? There is two distance. One is equidistance and one is the Manhattan distance. So this is the classifier you test. I give you around 10 minutes to test. We open the glass. Open the glass, open. Then we go to the classifier. The nearest, what we call it, is lazy because they are lazy. because you find K is the nearest. What is lazy? You go to cross validation and you start 70.6. Then you go to the IBK again. This is the K. K is the number of citroid. So you can change to the 5. Okay. Then you start again. 67. What will happen when you have a lot of citroid? $65. So you can, I give you around 10 minutes to play around with the K. K is the citroid. This is one of the easiest method in the machine learning model. So I give you 10 minutes. To try. Okay. The next method is a linear regression. Okay ke Pak Indra? Okay ke? Ada student dah dapat slide dia senyap dah. Pak Indra. Okay ke Pak Indra? Have you test? Okay ke? Yang lain okay ke?
Okay,
uh,
okay, ma'am.
Okay.
Okay.
Wah, Halim. So the next one is a linear regression. Linear regression, as you all know, is very good in terms of the three use of linear regression: determine the strength of predators, forecasting of effect, and trend of the forecasting. Okay. Forecasting. So linear regression. So the concept of linear regression, you have the data. Kenapa? Draw. You have the data, something X and Y. The data is something like this. The linear regression is draw a line. That's mean from here, in future, for example, there is raining, and rental bicycle. So for example, this is one is the raining is 60, rental bicycle is 10. Raining is 90, the rental bicycle is 5. So from here, in future, if the raining is 100, you can predict the rental bicycle is maybe lesser, is around 2. This is how the predictions of Sunny, sorry. Sunny, if the Sunny is 120, that means its rental bicycle is 10. 2, 5, 10. So if 120 degree Fahrenheit, for example, Fahrenheit, what are the raining? You can know the X and Y. Y and X. This is the line of the regression. So in the regression, you have a weight. The weight can know by inside the WEKA. So we try here. Linear regression working on the numeric value. Later, after lunch, it's a more harder because we want to make sure that from the nominal change to numeric. So I will stop until this 4 slide first. So data focus on the numeric values. You open the CPU. CPU data. So linear regression at the function. Linear regression, just start. So this is the weight that I mentioned. If you know the linear regression algorithm, this is the weight. In the linear regression, you know coefficient absolute errors, root mean, square, related, and absolute error. But this is the weight. Remember, when you draw a line, there will be a weight. This is the weight. So this is the linear regression. Classifier with non-linear regression. That means the leaf has no linear regression, focus on numeric. So we go to CPU also, CPU data. We choose the tree. VMI start, run it. They still have a similar with the linear regression coefficients. They also have a weight. If you want to see clearly using the tree visualization, the tree, there is a 5. 1, 2, 3, 4, 5, the leaf. So you go back the number of leaf. Okay, ka? So you test, this is the weight. LM1 same with the 3. This is the one, LM1. Here, LM1. Okay, if you can see. LM1, LM2, 3, 4, 5. How you get the 5? 1, 2, 3, 4, 5. You go back to the data. It shows here. LM1, 2, 3. Okay, ke? So this is the one. Later after break, we this is more quite difficult because you want to convert between the nominal to numeric. So a bit difficult. The step is a bit longer. So you can test. Then after test, we can take a break. Is that in Indonesia 12:15? Is it 12:30? Is it?
Yes, doctor.
So we meet again around 3 o'clock. Is that okay? Oh, 3 o'clock in Malaysia, but 2 o'clock in Indonesia, is it?
Yes.
Okay.
Yes.
We meet, you try and we meet again around 2 o'clock. Because this is a bit harder. How you want to change nominal to numeric? There is a lot of steps. Then after break, maybe we have sometimes to look into this part. Visualization. Okay. So I meet you around 2 o'clock in Indonesia, 3 o'clock in Malaysia. Is that okay?
Okay, doctor.
Okay, take a rest and feel fresh after you do the numeric. Numeric is whatever the data is nominal, but you want to run into the numeric. That some of you said gray. Okay, we meet around 2 o'clock in Indonesia. Is that okay?
Okay, doctor. It's okay.
Okay, see you all around 2 o'clock. Okay, bye.
Thank you, doctor.
Okay.
Thank you.
The binary. So firstly, kalau you all ambil the data, if you take the data diabetes, okay here, the diabetes and you classify it, you choose the linear regression. You can't. You boleh click, you can click, but you cannot start anything. Because what? The data in the decimal, but linear regression, usually they accept the binary, 1, 0, everything. So how you want to change the data? So in WEKA, you can change the data. This is the step. So change to the class with a no class. Change the data class with no class. If you can see class is 500. Class is 528. So you change to no class. Then you click choose. Go to filter. Okay. Filter. Then you choose unsupervised. Then you choose attributes. Then you choose nominal to binary. So you click here. Which item you want to first to last? No, you only want to change one attributes, number 9. Okay. Then you apply. You go the result. Go back here, you can see 0, 1, 0, 1, the class. So you go to the classification, linear regression. So here you can click the linear regression. Then you can start, run. So in WEKA, you can change the data to a nominal to a binary, which is a decimal to a numeric. So this is the step. So in the WEKA also, you can add your classification. Before that, this is the step. Another part, add value, click apply. Another part, you can linear regression with a output prediction. You can print your output. So here, output prediction. It's output prediction, you can choose. For example, you want a plain text. Oh, okay. So you run. So it come up all the prediction. What it means that 0, 1, 0, 1, 0, 1, what are the prediction and what are the error? The actual is 0, 0, 0, the prediction is 0.32. There is a line. Linear regression is the line. Is there anyone checking? Oh, okay. Okay. That is the beauty about the WEKA. That's why you can print the output. So the next one, you also can add in the classification. The classification, that means you choose the attributes, add classification. So here, all the output can go to the classification. So you can choose supervise because you want to add in the classification, add classification. So you click here. What you need to choose your classification. So you choose the linear regression because you want to do the output. So the output classification, you make it true. Then you, okay. Then you need to apply. This is the one. So you have a class, you have a classification on the linear regression. So you want to do the classification. This is the part. So the second one, you want to run. I I think they have to remove back. Oh. Okay, this is the one you add the classification. So another one, you want to run the regression 1R. One R, that's mean you want to revert back the data to from a numeric to a nominal. So here is you go to the class, no class again. Class to no class. Then you choose filter, attribute numeric to nominal. Attributes unsupervised, attributes numeric to nominal. Here. So you change what are the item number 9, you want to revert back. Okay. Then you apply. Something wrong. Numeric to nominal. Indexing 9. Numeric to nominal. Betul. It's supposed to go back to here. Yes, you come back to the normal 50 and 268. That means it's already go back to the nominal. So nominal to numeric and numeric to nominal again. Why? Because we want to run the data to classify the data between the class and classification. So you remove everything. Remove. So you classify, you want to classify using the 1R. Accept change to the class. Oh, okay. Why you cannot classify? Because you have a classification here. Because you want to classify based on the class. Understand? This is classification that you got the data, the output of the data from a linear regression. This the output prediction. You make it as an input now. So input, there is a class. You need to have the class yes and no. So after that, you move to here and you run. You got 72.29. You understand what is this problem? The problem, the output. Firstly, linear regression can only execute based on the numeric, which is 0 and 1. But the data that we have, the data that I export in the example, diabetes data. Diabetes data. Diabetes data is based on the nominal. So firstly, you change the nominal. Firstly, this change nominal to binary so that you can run the linear regression method. So once you have the data that you mentioned that your data require linear regression method, although your data is under nominal, but you can change the nominal to a numeric. So what are the output you require? So you said your data based on the linear regression, so you can change. This is the step This you can't click linear regression, but this is step how to change it. So this is the output that you have. Output from the linear regression. The output from a linear regression, the output of linear regression, you can add it into class. So the output, the results, you can put as the input to classify it using the 1R. It depends, this is the step, but it depends on your, like I mentioned earlier, it depends on your, what are the problems, what are your problems, what are the results. From here, it just show you the step. If you require the output to go in as the input. So the output, you go in as input, you can add in the class. So this is the add class. So you can use, what are the classifier? You can use linear regression or others. But in this case, we are using the linear regression. So here, once you have the output of the linear regression will be the input now. They can create one attributes. So to run the 1R, it teaches you back how to revert from a numeric to nominal again. So this is step to do the numeric to the nominal. You change the class, you can see back. Coloring is a numeric. You can see before that, is a black and white, 0 and 1. So you need to remove all the unnecessary things. You only need to know the class and the classification. So you run the 1R, make sure that you change here. If you change the classification, how you want to do the class, how you want to classify kan? Because the classification is only the data inside the linear regression. The data that you capture, this is all the data. This is all the data. This you, then you change back, then you execute. This is the results. And also you can change the basket, the 1R to 100, what will happen? Okay. So I give you 10 minutes to test. Is that okay? Two hands on. This is quite interesting because I also did not aware that inside the WEKA, you can change the type of data. That means in WEKA, you can change the type of data from numeric, from nominal to a numeric. So is that okay? I give you 10 minutes to do the testing. Okay, ka?
Okay, doctor.
Okay, 10 minutes, yeah? Please do, it's very interesting when you execute it. So until 163. Starting from 146 until 163. Okay. Okay, everyone already finished the convert the data. Really interesting for the WEKA. You can convert it, the data. Okay, everyone done? Can we continue?
Yes, ma'am.
Okay. So the next one, we continue on the neural network. So neural network. This is my PhD. I run a WEKA on my PhD. So artificial intelligence. So it's inspired by the brain, processing nodes connected, each node have weight and learning, and the weight or desire. So in the ANN, in the WEKA, they call it a multi-layer perceptron. So what I did on the classification of the blood. So the project is automatic classified leukemia cell. One of the blood cell is a top 10 in Malaysia. So I'm using the machine learning. So how about in Indonesia? How about the leukemia cell? Is that very critical in Indonesia?
Yes, similar.
Similar. Yeah, leukemia cell is quite critical. It's a top 10. Currently in Malaysia, the top one is around among the top 3 is stroke. Because of the pressure of the lifestyle. So most of the people who got stroke, they have high blood pressure. So the top 3 stroke. Currently in cancer is top 10. So I asked the medical doctor what is trigger the leukemia. They don't have the answer. So we also never know one of the cancer cell, leukemia. So in the leukemia cells, you only know that leukemia cells. But in leukemia cell, there is a few types of cell. The critical types of cell is the M3, which is not critical. It can be cured. But is M3, from my understanding, there is a leukemia that have a good leukemia and bad leukemia. Good gene and bad gene, which is when you give a chemotherapy, if the bad gene, they will make the leukemia become worse. But if the gene is very nice, very good gene, they consider it can cure. So M3, they have two types. One is bad gene and one is the good gene. So if you can see from your eye view, is for the medicals, they know what are the different. But for us, it's difficult. How I want to classify it? The images. So although you have a data images, you can run using WEKA. So this is explanation on the neural network. It's a series of algorithms to recognize underlying relationship, a set of data that process and mimic the human brain. So neural network refers to neuro and the artificial of natural. So neural network can predict modeling, adaptive control, application where they can train the data set, and they're also a self-learner. So do you know our brain? Our brain, there is a neuro. the small one. The neuron in our brain that from our eye give to the brain that give us this is the notebook. How to carry the information. Sometimes when you are tired, you cannot think. Because of what? Because of your weight in your brain, your neuron is not carrying enough information. This is the one, the weight. This is the input. You see the input. For example, I see the input is notebook. How the input is being translated to the output, the weight inside the brain. And neural network, the famous currently is now is a deep learning. Do you know the deep learning? Why they call it a deep learning? Because they have a very layer, the small layer. That's why the classification is more accurate for the images. That's why in deep learning, I'm not sure about the WEKA, they have a deep learning, but I know that the deep learning they have in the Python. One of the deep learning that my postdoc already done is CNN, Convolutional Neural Network. So when you do a final year project, why do you try the CNN, the latest algorithm? Convolutional neural network, deep learning. Deep learning is based on the neural network. So it's good to know what is a neural network. So my PhD is to do a classification of the using 15 attributes. What are the attributes? Medium, mean, variance, low, high for the RGB. So in the images, they have a red, green, and blue. Do you remember the data in iris, I think? Iris, is it? The bridge one. I think it's iris. No. This is iris. I think this is more on the images, Sentosa, Brazil, colors, and Virginica. CPU class segment. This is the one. This is the data from the images. Also, Pak Hendra, you have a data analog, is it? You are doing your PhD analog data, is it?
Yes, right.
Yeah. Also, the analog also you can transfer the numbering. Why do you try run inside the WEKA? Maybe are you getting the same or similar? All the methods. So this is the data that you can convert. Also me, I convert the data inside the WEKA. Why? Because I need to know whether I capture the images is correctly. This is the one. This is the one. I correctly clustering. You know the color. That's the reason I converted the color into the 15 attributes and I run the WEKA to justify whether it is the correct one or is this the correct clustering or not. So this is the data. The first one is class, average mean, average green, blue, variant red, green, and blue. This is the ones of the data. So when I run the classification, I got this result. Multi-layer spectrum is the highest. So it shows that whatever I capture the images is correctly classified. That's why my PhD using WEKA, the last part. The last part, because to prove whatever I classify it is correct. I'm more on the supervised. Supervised is you already train the data. This is the one. You already classify it, whether you are classify it correctly or not. This is the results. You see, 62, 82, 141, 140. That means it's actually is A, but it classified as B, and also it's classified as D. So the images of the density, the average is not accurate. So this is the one, the coefficient matrix. And this is the ROC is nearly to 1. Then it shows that multi-layer perceptron is one of the, to verify my classification on the images. Okay, after that is my supervisor is, after that he asked me to continue. Because when I got the machine learning, what I mean is artificial intelligence multi-layer perceptron is one of the best method. Multi-layer perceptron is one of the best method. You can use the MATLAB or any software to simulate it. Because in here, when you run the WEKA, you know the weight. How you will make it as better? That's the reason you have to do the coding by yourself. So WEKA is helping you to choose what are the better classification and you can enhance it. It's something like you can do as a preliminary testing. So maybe on your FYP final year project, you can use WEKA as your preliminary testing. There is a lot of data. Then after that, you can do your own coding to make it your preliminary. You have to prove that your coding is better than your test data in the WEKA. Okay. Is there any question? Wow, we finished class a little bit fast, Pak Hendra. This is the one that I just explored. Okay, is there any question on WEKA? We already go for the data visualization. It's really interesting, this part. But you have to follow the step. It took me around 1 hour. It's really interesting. Okay, is there any question on WEKA?
Excuse me, Prof. Waidah.
Yeah.
Okay. I have a question.
Okay.
So, greetings everyone. I'm Hafiz. I'm undergraduate student of SEU Unair. So it's quite interesting when you have this project to examine leukemia with using INN, right? And my question is that how do you handle working with is this project require us to working with health a professional, whether it's a doctor or scientist in health realm, because it's very crucial, right, to decide whether is it contain leukemia or not.
Yes, you have to working together with a medical doctors. Because one thing you have to take the data, because my work is more on the supervised data. So I refresh back. Supervised data, which is you already know. Which one is the M1, M2, M3, and 4. This is supervised, but you need to classify it. For me, M1, M2, M3, M4, I classify it based on the images, RGB, mean, median semua. Okay. That's
Okay.
why you have to work close with a medical doctor. I think Unai have a very good medical doctor, is it, Pak Hendra?
Yes, right.
So it's good that you can work together with a medical doctor. There is a data that my friend give me to analyze it, but until now I will try to take sometimes. It's bioinformatic data. If you have time, if you have medical doctor, you can try on the biomedical data. Bioinformatic data. There is a lot of bioinformatic data. And the area research is a bit lacking on the bioinformatic data. So maybe you can explore it in this part. Okay. This is the one. Data visualization using a Google Studio. Have you heard this before?
Yes, I've quite used it.
Oh, that's good.
Google Data and Video, right?
Yeah, data visualization. So you can click here. So because it's used for free. So you can do a report. This example is to take the COVID report live. This one is a workspace. So this is a connected. Open the registry using the Google login. So you go to the Google Sheet. In this is Google Drive, you go to Google Sheet. You have to export the data from the COVID virus. So how do you do import? This is the one. You import the data. So you can import all the data, but you to hide the below one. I think the below one is the total. Everything about the total, you can hide it. This is the live data. They say whatever changes in the COVID, it will be changes in your Google Sheet. So how you want to connect to a data visualization? You go to the report, you click on by name and make sure that you did not include the headers, yeah? Only the rows from the headers. Then you add. This is the one, COVID sheet. Then after that, you can add the data. Manage edit the data source. Resources. Here one, you can edit. If you edit more on the visualization, you can use your SQL command. SQL command is database command. So you edit, you come here, and this is the one. You can edit and add field. So this is the one that you choose. Total number of case words. You can sum total cases. Then you save. This you can take the resources, come out the add chart. This is the chart, and you can change here. Matrix total cases. Country and the others dimension. And this is the output. Can you try to get this type of output? COVID total number cases versus total number recovered. Is that okay? You just follow the step. Okay, ka? Then after that, everyone can show us how the output looks like. Okay. Okay, ka? Is that okay?
Okay, Doctor.
So you try to do the step. If there is any problem, you just inform me. So after that, it's already nearly finished. Then after that, we can share what are the output. This is the output. Total cases and total recovered. Oh yeah, this is the data studio. The slide with you all, okay? I see you half an hour. Is that okay? Then you can show us how's it looks like. Okay, ke? Half an hour.
Okay, Doctor. Is it
Okay.
half an hour or an hour?
Half an hour.
Okay.
Half an hour is around in Malaysia around 3 something, is it? 3. Half an hour is around 3:15 in Indonesia time.
Yes, Doctor.
So everyone can show us. Okay?
Okay, Doctor.
Okay. The slide with you. Or maybe you can make it better, it would be nice. It's really interesting when you have the Google Sheet, data visualization. So how you visualize the data, I'm not sure. Pak Indra, last time I already give a talk about the HCI, the user interface, is it? During one of my lecture. Last year, I think.
About what?
User interface.
Using
User
interface.
interface.
User interface. I think not yet.
I already give last year.
Oh, last year.
I think so. So the user interface is the data visualization, how you want to interpret your data. I think I will share the lecture. I try to find the lecture notes. I try to share. Okay, I see you another half an hour. And after that, you can share with us what are the output. Is that okay?
Okay, ma'am.
Okay.
Okay, please, Rifki, to share
Okay.
your assignment.
Okay, kita start with Kamel.
Okay. Excuse me, ma'am.
Yes.
Yeah, may I
Rifki.
share? Yeah, may I share?
Yeah, sure.
Yeah,
You already familiar, is it, with Google data?
no, actually, this is my first time as well, so
Oh,
I don't
okay,
know if
that's
this
good.
is right or not.
Oh, it's okay.
Okay.
Ah,
Yeah.
nice.
Yeah. So yeah, I follow the step from the PPT that Dr.
Yeah.
Waidah shared, and I don't know why, but the total cases and the total recovered is different.
You can go to the SQL. You can search
Where, ma'am?
the SQL
The
resource, I
SQL
think.
resource.
Add data source. Edit.
Did
Add field.
it field?
Then you add the data. For example, add just a total of the recovery. Okay, you go formula sum.
Some.
Okay, tick. Just make it total. Ada total recovery. Click. Then you save.
Okay, then I save.
So you go to the total. Okay, then you go back to the sheet. So here, total cases. You go to the sum. This is the sum. The left hand side. Total cases. This is the one. The already there.
Oh yeah. I change it to what, ma'am?
Just now you put what? Total cases, is it?
Yeah, this is total cases.
This is the one. The already there. The first one. I think the first one.
This one.
No, the first one. You type just now the field, the new field. What you type?
Oh, recovery.
Oh yeah, that's the one. So that's the total recovery and the total. You understand?
I don't quite fully understand.
You add. You go to the resources. You add whatever sum that you require.
Oh, I see.
So you put. So you go to the matrix. You change.
Yeah, this is the.
What are the name that you put?
I name it total recovery, ma'am.
So the total recovery, you already put sum inside there.
Yes.
That's the reason the matrix. How you change the color? You go total recovery, you style. Go to style.
Okay.
That's the fill. This is the color background. Down. Okay. Yeah.
Okay.
You can drag. So how you take the total recovery? You have to take the resources. Go to the resources. You add the fill.
Yes.
Then he called me back. Okay, understand?
Yes.
Okay, thank you. Nice. Rifki.
Yeah. I will stop sharing. I'm sorry.
Yeah, sure.
Yeah, thank
but
you.
it's good. Is that it's quite interesting, but you can play around with the chart, everything.
Yes. There's so many charts there that I'm still confused.
Nah, it's okay. It takes me a few hours also to understand it, to explore it. Actually, when you got something, you need to explore it. I think as a student, you can explore more rather than us, Pak Hendra. Because we are tied up with other things. So when I want to explore it, I only can explore it at night. Because during the office hour is quite tired. But for as a student, you can explore it. How about Zain Zaidi?
I'm sorry, ma'am. I'm not done yet.
Okay, is there anyone that you want to share?
I'm still not done.
It's okay. Oh, until what stage that you done?
I'm confused at total cases.
Maybe after this you can ask Rifki. Rifki already done.
Okay.
Are you same class with Rifki?
No, I'm fresh year.
Okay. How about Kima?
I have same problem with Zane. My total cases and my record count can be different table.
But you
May
have
I
to.
May I share my screen?
Yeah.
This.
Oh, okay. You did not remove the. You did not hide. You remember you need to hide.
In the spreadsheet.
Yeah. You escape that part. That's why you have a total here. You know, you need to hide. Below last, have you hide?
I think I already hide it in the beginning.
Below, you already hide it. Below.
Let me check it again. Where is it?
You already
I
hide
already
it.
hide it.
Okay, you go back to the table. Okay, they set up the data, country and others.
This.
Yeah. Country and others. The matrix also, total cases, you remove the record count.
Remove this
Yeah.
record count.
Try. So you have a total cases. You have the others country and total cases, is it?
Yes.
So you want to have a total cases, is it? You have to go
Yes.
to the alamak in BM. You have to drag the tambah control, I think.
Sorry, what, doctor?
Okay, you already get this. So you have to go inside the slide.
Inside what?
The slide 2. You have to go to the resource.
Resorts.
Okay. Add data source, manage data source.
This.
Yeah, then you click edit.
Edit.
Then you add column.
Column.
Column. Yeah.
Column. Okay.
So you eat, for example, total recover or total what? Click here, the name. Name column. You have to put name column first. Up. Yeah, that's the one.
Total.
Total cases, recovery, for example.
Recovery.
For example, so you go for the formula, sum, total. Okay, total what? Recovery. Here. Total cases, total recovery. Okay. Click. Apply, I think. Okay. So you go back to the sheet.
Where is it?
Tutup. Wait. Oh yeah, tutup, I think.
Yeah.
Okay. So you have to drag the tambah data, I think. Click at tambah data. No, tambah data there.
Tambah data.
No, dekat atas tu. Laporan jadual bukan kat situ, tu close. Dekat bawah halaman.
Where? Where is it?
No, not that one. Dekat page, add page, tambah data kat situ. Atas.
Is it total
No,
recover?
not that one. That one. On your left hand side.
Left hand.
Tambah data. Atas sekali. Bukan kat situ, left lagi.
Here.
Atas.
Oh. Is it?
Yes. Tambah data. Klik tambah data. I think tambah data kan risky. Bukan, you pegang gimana ni? Close. You go to resources, tambah data, add data hasilnya. Risky. Just now you put what? Add data, is it?
Which one, ma'am?
Yang before the sum tu.
Oh, before the sum.
Add data, tambahkan data.
I think I added chart, but scorecard.
Oh, okay. You go to the chart.
But scorecard only to show the
Yes, the chart. It's not tambah data before dah, tambah diagram. Klik the tambah diagram.
Diagram. Tambahkan diagram.
That's the one, total.
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 Is it
Yes.
Yes, that's one.
You have to drag. You have to tambah. Not change.
drag it here?
Add a new chart.
You leave it, you okay, add tambah diagram. There is another up. Not that one. On the
Below
left,
the asset. Below the asset.
up. Yeah. Click there. That's the one. Yeah.
Which one? Is it
Cartol score.
Yes.
Total. Yeah. Okay, you make it below or whatever lah. Yeah, you can put there. Okay, you click at the box. And you can add in just now. Close the, you go to the cartels, the setup.
go where?
Setup. No, that one
Setup.
on the right.
Hmm?
Below, that's one. The matrix. Total, what just now you put? Total what?
Total recovered.
Okay. Not that one. The setup one, the
metric.
matrix one.
On the left
It
side.
is.
Yes.
Yes, that one.
Just
Just
now you
add
put
it
what?
here.
You cannot drag. You drag, is it? Okay, you drag. Try drag. You have to change. Macam mana Rizky tolong explain in Indonesia.
I know, itu yang total cases diklik aja.
Matrix.
Yang metric total cases.
Yang mana, Mas?
Yang
mana, Mas?
metric total cases itu loh. Yang tadi cuman diklik aja. Yang di metric agak bawah.
Oh, ini.
Total
Ya.
cases ganti recovery.
Total recovery, yes.
Nah,
Okay kot, dia kena klik okay kan.
okay.
I think it's already changed. 3126. You make it larger? Besarkan. Tarik. Besarkan.
Still the same.
Okay. This is the total
Maybe
recovery.
I'm gonna explore it later.
Okay.
Maybe we can move on to another participant.
So is anyone want to share?
I want to.
Okay.
This is mine.
Oh, nice. So later maybe you can share with your colleague how to do it. Okay, Ali? Is that okay, Ali?
Okay, from the start.
No, later.
Okay.
Okay, it's quite nice, but you can put the color inside. You know how to? Just now I show the color. Click and set style.
Style.
Yeah, you can play around with the chart, everything. This is the live data from the COVID. So that means you can change it. Yeah. Okay, do you think it's easy?
Take a while to learn, but after get the hang of it, it's pretty easy actually.
Yeah. So this is the live data from the COVID. Maybe if you have the data, how you want to present the data using the chart or bar chart, but actually you need to know your SQL command. Because For example, you need a few tables to combine it. So your SQL command must be strong. So when I did my Microsoft data, I have to refresh back my SQL command. You learn your SQL command?
I haven't learned SQL.
Oh, you did not learn your database. Have you learned, Pak Hendra, did they have a database subject?
Yes,
So we have
Ah.
of course.
yes, we have math.
So inside the database, you have a SQL command. So later you can explore it, the SQL command. So SQL command, you have join data, everything. So I already, yeah. Good work, everyone. It's good that you can explore it. So we need to recap. Where's the Hilmi? Is it Pak Hendra? Siapa tadi? Lelaki tadi tu?
Rifki.
Halim.
Oh, Halim.
Oh, Halim.
Halim dah tak ada?
Halimnya masih join nggak?
Sepertinya Halim kepental, Pak.
Sekarang yang jadi moderator Mr. Ibrahim Hafizan.
Iya, habis.
Right.
Okay. So I want to recap back what we learned. So I share a few things. Yeah. So in WEKA, we learn about the open file. What are the documents that you require in the WEKA? If there is a free of data, you can explore. So whatever you have the data, make sure your data is converted to ARFF, which is can run. So filter can be used to change from numeric to nominal and nominal to numeric, remove the attributes, change the instances, everything. But they also can remove the data which is not being using. So whatever you look using the WEKA, make sure you understand it. Not just use the WEKA and just run the algorithm. So for example, I just open one of the files. Okay, this is a classifier. You have a Bayes, naive Bayes. Naive Bayes, this when you click, they have a lot of information about what is naive Bayes. Usually Bayes is famous one is Bayesnet and naive Bayes. I'm not expert in the Bayes, but you can try it. And the function is multi-layer perceptron. SMO is a support vector machine. So have you heard about, did they learn AI, Pak Hendra?
Maybe not
Semester later.
Yeah, semester later.
Okay. So in the functions, they have a multi-layer perceptron, which is an artificial neural network. SMO, what they call it as a support vector machine. Support vector machine is very powerful algorithm, but I'm not familiar with the support vector machine. It's too mathematical. So you can use it, you can try it, but your data, although the support vector machine is very good algorithm, maybe your data is not good for the support vector machine. So that's why in the lazy is normal, is using the k-mean, because they call it lazy is a simple algorithm, k based on the equidistance or Manhattan. I think they are more on the equidistance. Meta, which is I'm not familiar with. Classification via regression. Okay, MISC. This one, you have a decision table, but decision table more on the tree. Decision table is different, yeah, with a decision tree. Decision table, there is a table. Later you can explore it. 0R is a benchmark. Benchmark, when you use a benchmark, make sure that you are using a training set. That means all the data. So this is the one, and the tree is a J48 is a decision tree. Also, you have a random forest or random tree. 1R is the only you have a one rules only. So that's the one. So all these algorithm, the book of WEKA, you can download it. So you can, once you use, you can understand it. So when you use this, you can split. There is a 4 type of the test option. Use training set, which is 100% of the data used. Supply test set, which you have a supplement data for a real training data and the test data. That means the test data, they are using your supplement test data. Cross validation, there is a 10 stack that I inform you. There is a randomly, and also the percentage split. What are they? Split. Usually in the any of the journal, usually they put 90-10 or 70-30. So you can also output prediction. You want to text to HTML or plain text, whatever. You can explore it because I also not familiar with. I only know about the plain text. So the split, you can count it 1, 2, 3, 4. You can count until 10, and you all the output you can have the mean. Everything inside the slide. You can go. So for example here, you use the J48. So you click here, you can have the what are the batch number, what are the minimum number of object, unit prune, unit truncated or not. So you can start. Okay, this is the one. So in tree, you can visualize this tree. And also in any one, you can visualize what are the error. Okay. So also you have a visualization. For example, this one, what are you plotting? This is the data. And also you can use the rectangle to drag it. And you submit. It's a 0 because no data there. Okay. This is on the WEKA. So you think it's easy to use, but you need to know what are the variables that you need to change. Okay, this is the ROC for the neural network. Usually people are using the ROC. Coefficient matrix is more on the artificial intelligence, more on the classification part. This is a simple WEKA. This is the one. Okay. You choose, you can filter your data. I recap balik. So the next one is the visualization. Data visualization using the Google Studio. So this is how you visualize your data. You can play around with the current COVID data, but the things is very important here. When you add it the column, you represent it what formula? Sum, join, average. This is more on the SQL command. So from the data, you can convert to the bar chart, everything. Okay, ke? Today class training. So you get something or you did not get something? Because it's your weekend also. So do you get something knowledge?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. We got
ma'am.
something new. As personally, especially, I got something new by using Google Studio since that was really the first time I use it.
Yeah, Alhamdulillah. There is a lot of features. I also did not explore. I just explore a little bit. So it's good. Maybe in 1 year, maybe in 6 months or 3 months, maybe Rifki, you are better than me.
I mean,
So Pak Hendra, maybe Rifki can teach the whole class
Okay.
in another
Okay.
3 months. So Alhamdulillah that you get something new. I'm happy that you learn something. So is there any question? No. So you understand because the training more on the WEKA, but I think the Google data is something new. So that's why I share it with you all, especially the speech Google Studio. You are required when you use a data science. Data science, how you present the data. How you present the data. That's the reason I would like to share because people are looking for a data science.
Yes. Maybe like Tableau or Microsoft Power BI. Maybe.
Yes, Tableau and Microsoft BI is you have to pay, but this is free.
Okay. We look for free.
No, in USTEM we always use free. Maybe yeah. Actually, some of the university they have money. They are using the Tabula and the Power BI, is it? Business Intelligence. Yes, in Unai they using Power BI, is it? Tabula.
Not yet. we use similar. You use with free.
Free also.
Free access also.
So maybe you can explore it. You can present your data if you got a data. So whoever is doing the final year project, where's Halim? Halim already gone. so it's good to explore it, the WEKA and the data visualization. So is there any question? Ada tak? Ibrahim?
I think there's no question, right?
Okay, I'm happy that you all understand, you are interested with this sharing, more on the sharing part. Okay.
Okay, thank you so much, Professor Dr. Waidah Ismail, for bringing us to very productive session today, this weekend on Sunday. And I would also like to thank you for all the participants that have been joining with us from the very beginning until this afternoon. And before we close this session, we also like to, as part of the documentation, we will also like to symbolize our reward for Professor Dr. Waidah to please the committee share the certificate so we can take the documentation. Okay. I would like also to invite Mr. Hendra to be highlighted. So the documentation is including Professor Waidah and Mr. Rimuljo Hendra. Okay.
Okay.
Okay, Rifki, you can take the picture now. Maybe you can count 1, 2, 3.
Mute.
Yeah, okay. Okay. Get ready, everyone, because we're about to take a screenshot. Have your best post, make your best post. 1, 2, 3. Okay, perhaps one more time. Okay, 1, 2, 3. Thank you, everyone.
Okay.
Okay.
Thank you, Rifki.
Yes.
And again, I would like to, on behalf of the committee of this workshop, Introduction to Machine Learning to Support Sustainable Development Goals using WEKA, And we've been introduced to many things today, thanks to Dr. Waidah Ismail. We've learned about machine learning and learned new things also about WEKA and a little bit of Google Studio. And before we officially close this meeting, I will also like to announce to all of you to fill the evaluation form that have been sent in the chat. Maybe Rifki, you can send it again one more time.
Yes.
And, okay. And for the certificate, you will get emailed by our committee after you fill out the form. Okay, ladies and gentlemen, see you in next session. I'm Ibrahim Hafizan signing off. Wassalamualaikum warahmatullahi wabarakatuh.